next section of the electrical vehicle system, that is the block diagram of an electric vehicle system which is driven by a portable energy source. Okay, now let us consider this simple block diagram which has a charger. Charger will be connected to the energy storage system, that is battery. Why the charger is provided? Because the energy storage system battery is to be recharged again and again. Once the charging is over, it is to be used for the running of the vehicle, and once the charged energy is completed, we have to go again for the charger. So charger is the necessary here. Then energy storage battery system will be there. The battery system will be connected to the inside of the power converter. Inside the whole block, this system is very important here. It is connected to power converter. Then these power converters are connected to the electric motor. So power converter should be controlled by the drive control signal. Based on the drive control signals only, the power controls will be actuated, and these will drive the electric motor. So once the electric motor is started, the wheel has to be started, which is connected to the electrical motor through the transmission drive shaft. Okay. Now, how the energy flow actually will be taking place in an electric vehicle system? That is, start from the source of energy, ends at the wheels. Always it starts from the source of energy and ends at the wheels. With delivering a propulsion power, from the energy will be delivering from the energy source battery to the wheels with movement of the power. The path for this power and energy shown as a energy is known as a power train of a vehicle. So the whatever path, whatever the way for this power and energy flow which is going from the energy storage system battery to the wheel, that is called as power train of the vehicle. The electromechanical energy conversion system between the vehicle energy source and the wheels is the power train of the vehicle. See, if you look at the block diagram, uh, the electrical energy we are converting to the mechanical energy. So the stored energy of the electrical energy in the battery, that will be converted into the motion of the wheels. That means that the electrical energy is converted into mechanical energy. So electromechanical energy conversion system between the vehicle energy source and the wheel. So the whatever the energy is converting from electrical to mechanical, that is called as the power train of the vehicle. The power train has mechanical and electrical components. It has both the components, mechanical as well as electrical. What are all the components it has? Just we saw in the block diagram. Those are power converters we have shown, then electric motor we have shown, and then what is the thing we have shown? The drive system. Okay, shaft, that we saw in the block diagram. The fuel for electrical vehicle is stored in an energy storage device. Where the fuel is to be stored here? It is stored in the electrical vehicle in the form of electrical energy in an energy storage device such as a battery pack for energy delivered on demand. The primary source of energy for electricity generation for these vehicles varies, ranges from fossil fuels to solar energy. So from where we have to get the energy, that electrical energy, to the charging station, to the battery, that is also important thing here. How to generate the electricity? That maybe we can generate from using the fossil fuels, or we can have the solar energy or wind energy, whatever may be the source, but we have to basic energy generation from fossil fuels or to the solar energy, and it will be stored in a charging battery or energy storage device. The battery electric vehicles requires the power delivered in the form of electricity. So what the battery does here? The battery will be store the energy in the form of electrical energy. Okay. The battery electric vehicle requires the power delivered in the form of electricity to the vehicles through electric power transmission system. A high energy capacity battery pack is the most common energy storage device. See, in most of the electric vehicles, what is the most common energy storage device here, the battery pack, that should be a high energy capacity. It should have to store the more amount of energy, because we are using the vehicle for the transportation purpose. It has to go from 100 to hundreds of kilometers, or tens to hundreds of kilometers, so that much of power it needs for the electric vehicle. So that high capacity energy pack must be used. Electric machines require an electric drive to control the machine and deliver the required power based on the requested demands and feedback signals. See, electric machines require an electric drive. Okay, electric motor is there. One drive system will be there, which will control the machine and deliver the required power based on the requested demands and feedback signals. Okay, here the battery will be there. Okay, battery is connected to the your power converters and electric motors, that block will be there, and it has a drive system here. Okay, drive system has to send the signal to the wheels and get the signals from the wheels, both the directions. It has to get the signal from the wheel and send the signals to the wheel, so that based on the activity of the wheel and the drive system, it has to send the required demand of the electrical power to the wheels. Electric drives are made up of power electronic devices and electronic controllers. What are these electric drives? Okay, these are made up of mainly which have some power electronic components are there. Okay, and then some electronic controllers, maybe sensors will be there, thyristors, diodes, all these will be there inside the electric drives. The drives are electrical to electrical energy conversion device that convert steady voltage with fixed frequency into variable voltage supply for the electrical machine. See here, what are these drives? These are the electrical to electrical energy conversion devices which converts steady voltages with fixed frequency, steady voltage with fixed frequency into variable voltage supply for the electric machine. The drives can also process electrical power in the other direction, assisting the electric machine to convert mechanical power into electrical power, and the electric machine operates as a generator. Sometimes there is one term is called, that is regenerative braking. Whenever we apply the brake, that energy will be stored back inside the battery. Okay, in next coming lecture, so we will see that one. Here drives can also process one important um, one important work here, that will assisting the electrical machine to convert mechanical power into electrical power whenever it is required, when the electrical machine operates as a generator. We have an electric machine here, so whenever the electrical energy is required at the end user, means at the wheels, the electrical energy has to be converted into mechanical energy. Suppose whenever we apply the regenerative braking, the electrical energy whatever we used, which has converted into mechanical energy, that will be again converted into electrical energy. In that case, the electrical machine will be acting as a generator. So that will be assisting by the drives. DC to DC converter is used to DC power conversion from high voltage to low voltage levels, or vice versa. So why DC here? Because we are using the battery storage devices. Okay, battery as a storage device, and it always stores the energy in the form of DC. So that DC to DC energy converter is required, DC power conversion from high voltage to low voltage levels, and vice versa is possible. The motor is required to convert electrical power to mechanical power. So electrical motor is required for conversion of electrical power to mechanical power, and transmission is used for transferring electrical energy to the motion of wheels through drive shaft and gear mechanism. Transmission is used for transferring electrical energy to the motion of wheels through drive shaft and gear mechanism. So how, okay, we are converting the electrical energy to mechanical energy, it is fine. So how the wheels actually starts rotating? Okay, that is through the drive shaft and gear mechanism. So now let us consider some of the important components of electric vehicle. So what are the components of electric vehicle here? First one is, the important one is motor. Okay, motor here. The main function of the motor is to convert supplied electrical energy into mechanical energy. So obviously we all know what does the electric motor will do. Converts from electrical energy to mechanical energy. So here particularly we are taking brushless DC motor, we can call it as a BLDC, have been much focused for many motor manufacturers for electrical vehicles. These are more effective in terms of system cost. Why only the BLDC motors are used here? Because the cost of the system is very less, size is less and higher in efficiency, excellent controllability and also power saving than other motors. So having all these advantages of BLDC motors, we are using these motors in electrical vehicles. It has only two basic main parts. What does it motor contains? It has two basic parts, motor and rotor and stator. Rotor is the rotating part, as we all know, which carry a permanent magnet, and stator is a stationary part and containing stator winding. The structure of the stator is similar to the induction motor. So whatever we studied in electrical machine subjects. So the structure of stator is similar to always that is to the induction motor. It is made up of steel lamination with auxiliary cut for winding. So this is about the motor, that is electrical motor, which will be converting electrical energy into mechanical energy. Mostly we will use the BLDC motor because of its advantages like less cost, less size, higher efficiency, excellent controllability and also power saving than other motors. Okay. Now move on to the motor controller. What is this motor controller? In most of the electric vehicle, brushless DC motor is used, which is better than brushed DC motor. See here, most of the vehicle we are using, the other manufacturers are using brushless DC motors, which is better than the brushed DC motor. Permanent magnet DC motor, okay, brushed DC motor, permanent magnet DC motor. So these will be used earlier, but nowadays we are using the brushless DC motors. Brushless DC motors does not have brush and commutator. So the advantage is that here brushless DC motors does not have any brush and a commutator. The electric vehicle which uses brushless DC motor has to use motor controller, which helps to control various properties of motor to take sufficient current and voltage applied to the motor. So one more advantage here, that if you are using the brushless DC motor, we have to use the motor controller. What does it do? It helps to control various properties of motor to take sufficient current and voltage applied to the motor. So whatever voltage you supply or current you supply, but whenever you are using the motor controller, it will controls the incoming and outgoing of the voltage and current of the motor. When accelerating, suppose when we accelerating pedal is pressed, this linked variable resistor type controller gives signal to the motor controller to adjust the speed as per our needs. See, listen here. If you don't have a control over the motor, it will always rotate at its own speed, and you don't have any control over it. If you want low speed, the same speed of the motor will be always there. If you want less speed, the same speed will be continuing by the motor controller without any alternating the speed of the motor. So it will cause the problem for us. So that when we use the motor controller and we use the accelerating pedal is pressed, this linked variable resistor, so one resistor will be there, that type controller it will give the signal to the motor controller. So suddenly when you press the accelerating pedal, this resistor type controller will be give the signal to the motor controller to adjust the speed as per our needs. The motor controller has no power when vehicle is at its rest position. Okay, when the vehicle is at rest position, it doesn't do anything. But whenever we are applying force on the accelerating pedal, that signal will be sending to the motor controller. That motor controller will send the signal to the motor to send the voltage or current in a less or a more manner. By that we can control the speed of our vehicle by controlling the motor speed with motor controller. The battery. Battery is a main source of energy which is kept inside our electrical vehicle. The main function of battery is to store electrical energy. Most hybrid and electric vehicle use lithium ion batteries. Okay, most of the hybrid and electric vehicle use lithium ion batteries. This storage system is usually essential for hybrid electric vehicle, plug-in hybrid electric vehicle, and all types of electric vehicles. Due to advancing technologies, most of automobile manufacturers use rechargeable batteries. Of course, it is necessary nowadays because once if we use the chargeable non-chargeable batteries, once we charge it, we have to throw out, so that we have to use the rechargeable batteries. Next one is charging port. It is very important because whenever we are using the rechargeable batteries, again and again we have to charge these batteries. For charging purpose, we need charging port. Charging port allows the vehicle to connect to an external power supply in order to charge the traction battery pack. So external power supply is required in order to charge the traction battery pack. Where should we should get this external power supply? From the outside charging stations. DC to DC converters. These are the power converters, power electronic devices. It converts high voltage DC power from traction battery pack to the low voltage DC power needed to run vehicle accessories and rechargeable auxiliary battery. Next one is power electronic controller. Power electronics controllers, this unit manages flow of electrical energy delivered by the traction battery, controlling the speed of the electric traction motor and torque it produces. So what does it do? It will manages the flow of electrical energy which is delivered by the battery, controlling the speed of electric traction motor and torque it produces. So power electronics devices which have a which are completely controlling the energy flow inside the electric vehicle. Electric traction motor. Using power from traction battery pack, this motor drives the vehicle's wheels. Okay, using the energy from the traction battery pack, the motor drives the vehicle wheels by connecting through the shaft. Some vehicles use motor generators that perform both drive and regeneration functions. So these are some of the important components of the electric vehicles. So here these are transmission, onboard charger and traction battery pack. So what does it transmission? The transmission transfers mechanical power from the electric traction motor to drive the wheels. Okay, we saw in the diagram. So this is the electric motor. Here one drive was there, drive and shaft, and these are the wheels. Okay, this drive is connected here, and here it is connected to motor. Once the motor starts rotating, the drive which is connected to the vehicle which drives the wheels start the motion rotation of the wheels. Onboard charger. Onboard charger means it takes the incoming AC electricity supplied via the charging port and convert it into the DC power for charging the traction battery. So onboard charger means outside whenever we can install this one. It normally supplies the AC electricity, but for our electric vehicle we need a DC because our battery pack is DC. Okay, that's why this will convert the AC to DC traction battery. It also communicates with the charging equipment and monitors the battery characteristics such as voltage, current, temperature and state of charge while charging the pack. Okay, once we put the battery for the charging, who has to check the properties or the characteristics of the battery? Because once we put it to the charging, we have to we have some time frame, right? Because voltage level, current level, temperature level, and state of charging, state of discharge, all we should know, okay, for the charging purpose. So once the required level of charging is reached inside the battery, it has to stop the charging of the battery because of overheating will be there, okay, some other disadvantages of the battery, okay. That's why it also onboard charger will also communicates with the voltage, current, temperature, and state of charge, the characteristics of the battery. Traction battery pack, it stores electricity for use by the electric traction motor. So what is this traction battery pack? It stores the electricity for use by the electric traction motor. Okay, these are all the components of the electric vehicle. This is the general layout of electric vehicle. We will see in the next video. What does it contain? General layout of electric vehicle. Actually, how this complete electric vehicle will work. When we apply the brake, accelerator, how the energy will be flow from one component to another component.